you. Yeah, I emailed it yesterday. I got an email reminder from somebody. Can you email us that? And I'm like, yes, I can. I went on a walk around the lake after work and I forgot what I was doing. Well, I hope you enjoyed the weather. Looks like next week will be pretty good too. I went for a run yesterday. Everybody and their mom and their dogs were out walking yesterday. It was kind of nice. All right, so friendly reminder, IRB proposal coming up on Friday at 11:59, along with your consent forms and your debriefing forms. So friendly reminder to you, when I say cite 3 sources, I'm concerned more about the sources within the context of the actual IRB application form itself. If you want to cite in your debriefing form, I'm fine with that, but I'm mostly wanting you to cite sources within the application when we're talking about background material. And if you have questions, so here's the deal. I think it's supposed to rain tomorrow. I get to play in the band again. I get to play tuba again because apparently the wind ensemble has been without a tuba for a little while, and it's time that their ringer came back. But I'm probably not going to go tomorrow. So here's what this means. I have to walk Smedley at about 3 o'clock, but I will be available around 2, and I will be available from 4 to 5. I might have some time between 10:35 and 11. So if you want to meet with me tomorrow for any last minute questions or anything like that, that is a great time to go ahead and reach me. I would love to help you out. And remember too, that these come in parts. So I'm going to be pretty generous with these. So now that we have that, here are a couple of other announcements. We have quiz number 5 that we'll post on Friday. It will be due on Tuesday. And not to scare you, remember that the first draft is 0 points. The first draft of your introduction, we're going to do some peer review next Thursday. It's 0 points. So if all you bring in is a paragraph, pardon my language, we will make it the best damn paragraph ever. I will give you feedback. 2 of your classmates will give you feedback. If you are not going to be here, or if you're zooming in, so Clelia, I know that you're zooming in. If you want to find a classmate who will peer review your work, it can either be during class time or it can be another time. You are more than welcome to email some of your classmates and get peer review. And if you can't be here on Thursday, I would highly, highly, highly recommend that you get peer review from the Writing Center. The Writing Center is an excellent resource. They will be able to help you out. You will be absolutely fine there. And I would recommend you use them. Dr. Green always wants more people to come to the Writing Center. All right. How are we doing otherwise? Okay. So we're kind of at the midpoint of the semester. So this is usually where people start running on fumes. Is there anything that I could be doing to help make this week a little bit easier? No, I'm not canceling class. Nice try. But I can tell bad jokes. I can bring in gritty, whatever you need that will help you feel a little bit better this week. Just to let you know, for those of you that came in kind of late, if my phone rings and it's from a certain number, I am picking it up because I'm waiting to hear back about leftover vaccine doses, and Dr. Gilchrist really wants hers. Not that it would really change that much this semester, but I still want it. All right, so with that in mind, let's go ahead and begin. So the last time that we were here, we were talking about different ways to measure variables. 16th century art in Italy. Well, if this weren't research methods, I would teach that. That sounds fun. So what we are going to talk about today is we're going to talk about scales of measurement, and then I'm going to show you a cartoon about surveys if we have time. because we're going to start talking about surveys and observational research next. So let's talk a little bit about scales of measurement. So this one is going to be kind of interesting. So when we look at scales of measurement, so one of the things that I've kind of discovered that people sometimes have problems with when we're doing research methods. So one of the things that I used to do with the previous research methods classes before I did a replication study was we would make our own survey questions, and then we'd have the entire class answer this big giant survey that I had made of all of their questions, and then they'd analyze that data. So I was reading 10 different papers on 10 completely different topics. It's a lot easier to read 10 papers on the same topic, which is why I like the replication study better than the survey study. But here's what we kind of discovered. The way that you ask a question and the way that you measure a variable affects the kind of data analysis that you can do. So there are rules. There are rules to what types of analyses that you can do and what types of analyses that you cannot do based on the way that you collect your data. So for example, if I ask you, do you like vanilla ice cream? Yes or no? Who here likes vanilla ice cream? Who does not like vanilla ice cream? Okay. I mean, I like other ice creams better, but I'll still eat vanilla. Ice cream is ice cream, y'all. But that I can't necessarily get an average in that particular instance. I can't get an average based on 3 people liked vanilla and 5 people didn't, for example. I can't get an average that way. I can't get a mean that way. And because I can't get an average that way, that means that there are some types of statistical tests that I cannot do. So we're going to talk about scales of measurement and talk about some of the different ways that we can analyze the data that we have. So first of all, we need to think about measurement. So to understand what scales of measurement are, we need to actually think about measurement. And I'm going to ask you a quick question because it's about 70 degrees outside and it's kind of warm in here. Is it okay if I take off my cardigan? Okay, there. Dr. Gilchrist has nice guns. We know. I have nice arms. I work out. So we need to talk a little bit about measurement. So measurement is when we systematically assign values to represent attributes of different types of variables. So for example, so anytime that we are measuring, we are assigning a value to an attribute or a variable of interest. So one of the easiest ways to kind of think about this is you can think about some of the different ways that critics rate movies. So right now, you are looking at a few different well-known movie critics. Gene Shalit is in the hat. And then we have the late Ebert. And I believe that is, I believe that's Roper, not Siskel. And then you have Leonard Maltin. All of these are movie critics, and each of them rate movies in a different way. So does anybody know how, does anybody know some of the different ways that we can rate movies? One of the pictures has a hint. Well, no. And so how many of you have ever heard somebody go, this movie got 2 thumbs up? So that was a really famous rating method that Ebert and Siskel, and then later Ebert and Roper did. So if they liked a movie, it got a thumbs up. If they didn't like a movie, it got a thumbs down. So if you got 2 thumbs up, that means that both of them liked the movie. So we can measure movie rating with the number of thumbs in this example. So in the middle, they're actually, the trick is they're both holding up thumbs. They're doing a thumb war. Don't challenge me to thumb war, y'all. I'll lose. Now, Gene Shalit does something a little bit different. He rates movies with a star system. So in this case, the measurement is with stars. So a 5-star movie is a really, really good movie. A 1-star movie or a half-star movie is a really bad movie. Like we're talking like The Room or Manos Hands of Fate or something like that. And then finally, we have Leonard Maltin. Leonard Maltin probably has one of the more common ways of rating movies. He rates movies on a scale of 1 to 10. So all of these are different ways of rating movies. Are there other ways of rating movies that I haven't mentioned here that could be used to measure a movie rating? Anybody go check out Rotten Tomatoes? How does Rotten Tomatoes measure movies? So they do a percentage and it's 0 to 100. Are there other ways of rating movies? So I like to check out a website called the AV Club. They rate theirs A through F, like a grade. So all of these are different types of measurement. I long for the day where I will not have to drink hot tea through a straw. Later, it will be replaced with Diet Coke. Okay, so the reason that we have to talk about scales of measurement is that scales of measurement give us rules. So measurements, the type of measurement that we do affects the kind of measurement and the kind of analysis that we can end up doing on data. So the rules are rules of assigning scale values to measurements. So for example, representing movie quality with the number of thumbs. So what if we did a study looking at the favorite ice cream flavor of students here at Cotty College? What would we do if we wanted to look at frequency? So another way of thinking about frequency, y'all, is a count. So we could count how many students liked a certain flavor, right? So what would we do if we wanted to look at frequency? So how would we study the favorite ice cream flavors of Cotty College students?
Based on how often they eat that ice cream.
Okay, so we could say, how often do you eat vanilla? How often do you eat chocolate? How often do you eat your favorite that is not listed here? So that's one possibility. Is there any other way that we could get that data? We could ask people, we could give people a list of ice cream flavors and ask them to rank their favorites. We could see how many people list a certain ice cream flavor as their favorite. Emily, I really like the method that you came up with, because when you say how often per week do you eat this flavor, you can actually get an average from people with that. You could combine all of the scores that people say, how often they eat, and then you could find out that the average person eats vanilla ice cream maybe twice a week, but they eat cookie dough like 5 times a week. Or if they're my partner, they eat any kind of ice cream 7 times a week. Yeah, we're an ice cream house. So scales of measurement let you know what kind of operations are permissible and what kinds of analyses are permissible. Now, for those of you that are going to be here next semester for 311 with the psychological statistics, you'll get a nice refresher on this. So if you forget, oh, don't worry, Dr. Gilchrist will remind you. You're like, please don't. I'm sorry, but I must. Okay, so the 4 scales of measurement are as follows. Here are their names, and we're going to go over each of these in more detail. So we have what is called the nominal scale. We have the ordinal scale. We have the interval scale, and we have the ratio scale. So a trick to remember them is they spell out the word noir. like Spider-Man Noir. Okay, so we're going to start with nominal, and some of these are going to sound really familiar. So we talked about the difference between quantitative and qualitative. So nominal is actually going to be one of the easiest ones for you to remember because it looks very much like qualitative data. So anything that is on a nominal scale of measurement, they are representing qualitative differences in your attribute of interest. So for example, if I asked you a political affiliation and I gave you a few options to choose from, like Republican, Democrat, or Independent, that would basically be it. Now, can I get the average of what people put here? So if I have 55 people saying they're Republican, 35 saying they're Democrat, and about 16 getting independent, can I get the average political affiliation from that data? No, but I do have counts, and that matters. So I have counts. So here's what this means. If you're looking at categorical data like this, you can't get an average. You cannot take the average value. You can say what the most frequent value is. You can say what the least frequent value is, but you're only going to be able to do certain types of analyses with this kind of data. So if you come to me and you're like, Dr. Gilchrist, I need to get a confidence interval for this data, I'm going to say, but we can't do a confidence interval with this data. We can't do a t-test with this data. We can't do an f-test with this data. I can help you find something that will work for you. We may have to do what's called a chi-square test because a chi-square looks at frequencies, but I can't get an average with this data. So how do you know that you're dealing with a nominal scale of measurement? Generally, you are going to notice that they are a set of labels or names for mutually exclusive categories. You cannot be both a Republican and a Democrat. I mean, you probably could, but what I mean is that when you are answering these categories, you can only pick one. So if I say, name your favorite flavor of ice cream, you can only pick one. So everything is mutually exclusive. So for example, your major. Now I know that some of you are double majors and that does complicate things, but unless you are double major, so let's leave double majoring out of it for a minute. If no double majors existed, you cannot say you are both a psychology major and a biology major, for example. Obviously, double majors kind of throw a wrench in the works, so maybe we have a category specifically for double majors. But you can't be a double major and also solely be majoring in like English. You're double major, so the English is probably in that. So they're mutually exclusive. You can't be in both categories. Few people are looking a little confused. Do we need to clarify? No, we're good? Okay. Now, here's what's really critical. So if we are trying to score this data, so if we have people mentioning their favorite ice cream flavor, for example. So here's chocolate. Here's vanilla. And here's strawberry. Nobody ever picks strawberry. Does anybody really like strawberry ice cream? I occasionally get in the mood for it, but generally I'm like, no. I mean, you can make it with real strawberries. So here's what's kind of weird. You say that. How many of you, to get off topic for a second, I'm curious. How many of you like the mint chocolate chip that's colored green? How many of you like the mint chocolate chip that's colored white? Okay, clearly nobody here likes mint chocolate chip, but I'm actually weird. I like it when it's that fake green color, and it's weird to me when it's white, even though that's probably the color it should be. So here's the thing. So let's say that I was putting this, so I'm putting my data into like Excel or a software program, and I use a number to basically label these. So number 1 is chocolate, number 2 is vanilla, number 3 is strawberry. So you could potentially make the argument, I have just turned qualitative data into quantitative data. And to that I say, here's why. The order here is arbitrary. Could you imagine a different numbering system where I number vanilla with 1, strawberry with 2, and chocolate with 3? Or I could do this. So maybe I code chocolate with a star. I code vanilla with a smiley face. And I code strawberry with a really badly drawn pair of cherries. Here's my point. My labeling system, I can use whatever symbol I want, but the relationship between the item and the symbol that I use to represent it is arbitrary. I could make this A, B, C. There's no relationship between the actual item and the label I choose to give it. So don't assume that just because you're coding something with numbers that it automatically means it's not nominal. Dr. Gilchrist's favorite ice cream has 3 favorite ice cream flavors. Netflix and chilled, the non-dairy version. Anything that is pistachio flavored, because I'm secretly old. And peppermint stick, because my birthday is 2 weeks before Christmas. Okay, let's talk about ordinal scales of measurement. So nominal scales of measurement are about mutually exclusive categorical data. An ordinal scale of measurement is when different scale values represent relative differences in an amount of an attribute. So it implies that there is some kind of ranking system. So values can be represented by numbers. So this person came in first place, this person came in second place, this person came in third place, or it can be represented by category labels, such as ages. We can put somebody in the category of children, teenagers, young adults, and so on. And there's a ranking there. There's an order there because we're going from youngest to oldest. By the way, y'all, here's another very well-known ordinal scale of measurement. Freshman, sophomore, junior, senior. This is another ordinal scale of measurement. Now, here's kind of the catch, though. It doesn't really tell us anything about the distance between the rankings. So here's kind of my example. So I want you to imagine that we're all competing. Let's imagine that we're in an alternate 2021 and you and me we're all in the Olympics in Japan. So we're all in the Olympics and we're all running. And Maya gets the gold medal in bobsled. and then Julia gets the silver medal in bobsled. And Clelia gets the bronze medal in bobsled. Now here's my point. Let's imagine that Maya's time on the bobsled with her teammate was 1 second faster than Julia's. Does that necessarily imply then that Julia was 1 second faster than Clelia? No. So here's what's really important. It doesn't tell us anything about the distance between the rankings. So for example, let's go back to freshman, sophomore, junior, and senior. And y'all, because I am an academic advisor, I know way too much about credit hours. So if I'm not mistaken, freshman is basically, in terms of credit, up to 30 credit hours, yes? So freshman is basically 0 to 30. Sophomore is 31 to 60. Junior is 61 to 90. And senior is basically 91 to 120 credit hours. Now, here's my point. So who here is a sophomore? Okay, we got a couple of sophomores. How many credits do you have right now?
No idea.
Okay. Does anybody know how many credits they have right now? Okay, Maya. You have 64, so you're a junior. Okay, who here is a senior? Anybody? Okay, Mathilde, how many credits do you have? Okay, that's okay. But here's my kind of point. Okay, 96, so like that's about 30 credits difference between you two, ballparking it. Does that necessarily mean that every other junior is going to have a 30 credit difference between themselves and Mathilde? No. I know some sophomores who are at 59 credits. And they're 1 credit away from being a junior, but because of the way we treat it, it's treated like they're a year apart. That may not actually be the case. Are all children the same age? No, they're not. The difference between ranking of a child and ranking of a teenager could be as small as 1 year. So maybe a 12-year-old versus a 13-year-old. We put them in 2 different categories, or it could be a 5-year-old and a 19-year-old. So just because you are in different categories does not mean that the distance between those categories is always going to be the same. The difference between a freshman and a sophomore could be as little as 1 credit. A freshman with 29 credits and a sophomore with 30 or 31, or it could be as much as a 60 credit difference. So these rankings don't tell us anything about the distance between them. For example, let's imagine that we all do the color run together in June around Arrowhead Stadium. Can you tell what Dr. Gilchrist wants to do this summer? Yes, I want to run around Arrowhead Stadium in Kansas City and have people throw colored powder at me while a unicorn like dances and stuff. But let's say I come in first place. Yeah, right. First of all, they don't do placing, but let's imagine that they did. And let's imagine that I'm much faster than I actually am. And I finish in like 19 minutes and 25 seconds. The next person comes in about 30 seconds later and they take second place. That does not necessarily imply that the third place person will also take another 30 seconds. They could be right on that second place winner's heels. So ordinal scales of measurement are actually used a lot. When we talk about US News and World Ranking and Coddy's wonderful rankings and things like that, that is an ordinal scale of measurement. So now we're going to move on. We have what is called an interval scale of measurement. Now, there are some types of analyses that you can actually do with an ordinal scale of measurement. If I'm not mistaken, and bless you if somebody just sneezed. Bless you. But we do actually have, for ordinal, if you're curious about what types of analyses we can do something with an ordinal scale called Spearman's rank order coefficient. I'm about to remember how to spell. So you can do this with ordinal scales. But if you want to do like a correlation coefficient, or if you want to get an average of something or do a confidence interval, your data usually will need to be in either interval scale or ratio scale. So interval and ratio are often going to be the scales of measurement that we are dealing with. Not to say that a nominal scale is bad or an ordinal scale is bad, but it does kind of limit the types of data analyses that you can do. And unfortunately, Dr. Gilchrist doesn't do a lot of chi-squares. But if you would like to do a chi-square, I can show you how. And I can, more importantly, I can find you software that can do it for you, all the hard work for you. So an interval scale kind of works like an ordinal scale does. Here's what's different about it though. Equal distances between values reflect equal differences in the amount of attribute being measured. So for example, temperature, either in Fahrenheit or Celsius. So I'm not really very good with the metric system, but one of the things that's kind of nice here is that Fahrenheit and Celsius are both on interval scales. So for example, I'm working with Fahrenheit here. The difference between 75 and 80 degrees is equal to the difference between 80 and 85 degrees. I would love it to be 80 degrees. And some of you are like, no. And that is okay. It takes all kinds. I am just not a cold weather person. I am a hot weather person. And yes, summer is my favorite season. Celsius works the exact same way. The difference between 0 degrees Celsius and 10 degrees Celsius equals the difference between 10 degrees Celsius and 20 degrees Celsius. Here's the catch though. So for Fahrenheit, here's something that an interval measurement does not have. It does not have what we call a true zero. When I talk about a true zero, zero means absence. So here, what is temperature? I know we just turned this into a chemistry or physics class, but what is temperature technically a measure of? Anybody? Anybody got a science class this semester? You're like, we already did all our science classes. Temperature is a measure of molecular movement, right? So the more that the molecules collide, the greater the temperature and the greater the collisions. So a true zero would mean a true absence of molecular movement. Do you have that at 0 degrees Fahrenheit? No. You can still move when you go outside when it's 0 degrees. You did it a couple of weeks ago when we had really cold weather. Nobody immediately froze into a statue and stopped moving because all of their molecules froze. So we know that Fahrenheit's not a true zero. Is Celsius a true zero? Nope. You know what it is? Kelvin. So we have absolute Kelvin with 0. So that Kelvin is actually what we would call a ratio scale. But both Fahrenheit and Celsius are interval scales of measurement. And then finally, we have a ratio scale. So with a ratio scale, just like we see with an interval scale, equal distances reflect equal differences in the amount of an attribute, and it has a true zero, in which 0 means you don't actually have that thing. So for example, if my annual income is 0, I didn't make any money last year. If my time to respond is 0, that means that I didn't respond. If the length of something is 0, it doesn't have any length. So all of these are ratio scales. Their true zero reflects an absence. So you might be asked on this quiz to identify different scales of measurement. Email me if you have any questions. We do not have class on Monday, but I'm not going anywhere this weekend. Like probably in about 3 or 4 weeks, if we have a 3-day weekend that starts on a Friday, I might day trip to Kansas City and go to Trader Joe's and buy groceries that I really want. But I'm not doing that yet. So if you need me on Monday, I'll be around. I can email you. All right, everybody good? Okay, So I want to finish up by talking about accuracy, reliability, and validity. And I will kind of let you know that the example that we are going to be using here involves weighing yourself on a scale. So if anybody is a little uncomfortable with that, I'm just letting you know in advance. But I'm trying to work with ridiculous examples here, so I'll be working with myself. Okay, so I want you to imagine that I get on the scale. So I have the scale on my bathroom. My health is really important to me. And I get on the scale, and let's imagine that I weigh about 148 pounds. So I get on the scale, and let's say I weigh myself and I get the following measurements. So in scenario 1, I get 148.5 for all 5 measurements. Now let's say with scenario 2, I weigh myself and I get 148.5, 149, 148, 147.8, 149.2. Which of those scales would you rather have at this point? Yeah, which one? Oh, I'm sorry, I see hand, you know how I get. Which of these scenarios would you rather want to deal with? Which scale would you rather have, 1 or 2? If you have to have, well, and some of you are like, we do have a third option. Who would say, I don't want a scale in my bathroom at all? And that is totally valid. But why would you pick 1, Emily?
Because the numbers are more consistent.
Okay, so we've got some consistency here. Now, here's the catch, though. What if I'm actually 175 pounds? Well, there's part of me that's like, you know, I might keep that scale. It keeps me feeling good about myself. But if I'm actually 175, what should I do with that scale? If I probably fix it or get a new one because it's not accurate. So part of the reason that I bring this scenario up is that there's a big difference between reliable or consistent measurements and accuracy. They are not the same thing. Now, here's my point. Here's kind of my point. Can my scale tell me anything about how extroverted I am? Can it tell me if I'm a good person or a bad person or a kind person or a beautiful person or anything like that? No, it's just measuring my gravitational pull to the earth. That's it. It can't tell me anything about how extroverted I am. It can't tell me anything about my worth as a person. This is my reminder, don't let your weight determine your worth. Okay, that is not for you. That's from last year. Our deadline is actually due on 11/59. But one thing that I would kind of let you know, these are old dates, so let me change them while I got you here. So it's the 4th, so it'll be 11. Homework 5 is going to be based on that draft, and that's going to be due on the 12th. And oh gosh, those dates are just staring me in the face. I'm like, I must fix them. There, let's save it. Display settings, duplicate slideshow, and we'll save it after, so that way I don't make that mistake again. Okay. Yes. Yeah, you remember the introductory paragraph? So part of the reason that I included the IRB proposal, you can take some of what you wrote in that proposal, like the background information and your goals and your purpose and some of the methodology, you can actually work that into your intro. And I'll be looking it over too and giving you some feedback. So here's the deal. I don't always, so if you do this, I don't mind. If you're going to do like, first this paper said this, and then this next paper said this, that's okay for the early drafts. I'll kind of work with you so that you can integrate those sources. But honestly, if you only bring in a couple of paragraphs, that's okay. And if you don't bring in anything, that's fine. It's 0 points. but you're going to make, but your first draft for points is going to be due 2 weeks after that. So if you have something, anything down on paper, that's going to be easier to work with than nothing. So it's kind of, it's up to you. I make it 0 points so that if a lot of stuff's piling up on you, you can skip it, but you're going to have to pick it up pretty quick. So definitely ask questions. Let me look at drafts. Go to the writing center, collaborate with each other. Don't plagiarize from each other, but you know what I mean. Okay, so let's talk a little bit about accuracy. So accuracy is how much the measure's results agree with a known standard. So for example, our thought experiment. If I know what my weight is, and I get something that feels very off from that, that's a problem. That is an inaccurate measurement. If I have a stopwatch, so I do some working out, and one of the things that I've had to do this week is, y'all, I had to hold a plank for a minute 3 times. The muscles between my ribs are so sore. But I want you to imagine, for example, that I put on my stopwatch that I need to do a plank for a minute, and my stopwatch keeps going for 3 minutes. That's going to be the longest minute of my life, and it's actually 3 minutes. That is not an accurate measurement. Now, there are different types of errors that can happen when you're trying to get an accurate measurement. So for example, this happened with my partner's old scale. So some scales are digital. The scale that I have at home is digital. But my partner used to have a manual one, and it always added 10 pounds. So I'd get on the scale at his place back when he was living in Colombia, and I'd be like, whoa, and then I'd get off the scale and it'd go reset itself at 10 pounds. I'm like, oh, this is what we call a systematic error or bias. The amount of error is always consistent with each measurement. So you might find this with instruments that are slow. So computers tend to get slower as they age. Maybe it takes them more time to process something. So systematic errors are pretty common. Maybe this happens with a poorly designed test that we give to everybody, or a scale that's broken, or technological equipment that's getting slower over time. So this is systematic. Everybody gets the same amount of inaccuracy. So this is actually, accuracy is really easy to get for things like speed or force. So for example, if you want to look at the speed that somebody responds to something, we have great technological software that will basically record how long it takes you to press a key. And I can get that on the millisecond level, and that's pretty good. So it's really easy to get accurate measurements for things like speed and force and weight. It's a lot harder to do that when you're dealing with psychological variables like accuracy in personality inventories, IQ, diagnostic tests. Like the rate of misdiagnosis for certain types of disorders is pretty interesting. Like I know many people with certain types of personality disorders that have occasionally been diagnosed as having bipolar disorder and vice versa. So psychological variables are going to be a lot harder to get accuracy on because we don't necessarily know what the standard is. Now, reliability is different. Reliability is all about how consistent a measure is. So the first scale in our thought experiment was much more reliable than the second one. Why? And by why, I mean, how did we know it was more consistent or more reliable? Because it gave 148.5 over repeated measurements. So here's what's really important. Reliability does not imply accuracy. Now, if we want a good reliable measurement, a reliable measurement is important. If I go in to take an IQ test and I walk out with 145, I should probably get something pretty close to 145 the next time I take the test. If I walk in and they go, yeah, you got an IQ of 30, I'm going to be like, I would like to take a look at your test because I think something is wrong here. You don't want to have that kind of unreliability. Now, something else that you need to notice, this is really critical. You are not guaranteed to get the exact same measure every time. So how many of you took college entrance exams more than once? Yeah, me too. Did you get the exact same score? No, you usually don't. I didn't even always get the same exact score on an IQ test, and we have a tendency to treat IQ as being something that doesn't change. So this is what is known as random measurement error. This happens. Your score is going to bounce around a bit. This is what we call random measurement error. So one of the things that you kind of need to know about data analysis, and when we talk about data, is that we tend to think of measurement like this. So imagine that you have a score. It could be an IQ score. It could be a test score here in the, well, not in this class because we don't do tests. It could be a test score in class. It could be like your GRE score or something like that. So your score, and we're going to go ahead and call this the observed score. So this is an observed score. An observed score is made up of what your true score actually is, plus error, that randomness. And ideally, we want to try to reduce that random error as much as we possibly can, so the more accurate these become and the more reliable this becomes. So one of the ways that we can do this, and part of the reason that I brought up tests, is because this comes up quite a bit. Now, if you are interested in the psychology of testing, or if you want to give people personality inventories or diagnostic tests, if you decide to go to graduate school and you like this kind of stuff, I cannot recommend a class called psychometrics enough. Now, it's pretty number heavy, so if you don't like numbers, it may not be for you, but psychometrics is all about things like test-retest reliability. So if we want to make sure that this is accurately measuring something, we are often going to administer the same measure to the exact same participants more than once. And we want to make sure as much as possible that these testing conditions are equivalent. We don't want it to be like my human memory class, where one semester I was in the psychology building and then another semester I was in an engineering building where we heard constant jackhammering outside. We want the conditions to be as equivalent as possible. Now, if we want to do this with measures of things like personality or intelligence, we don't have to do these tests immediately. We can wait a few weeks. Why? Why can we wait a few weeks between a personality test or an intelligence test? Why would we be able to wait a few weeks between IQ tests, for example? Anybody? Is your intelligence going to change a lot within 2 weeks or 3 weeks or 4 weeks? You're like, I don't know, Dr. Gilchrist, I could watch a lot of really dumb TV shows. I could, yeah, you can't modify your IQ by watching TV shows. What about your personality? Is your personality going to change a lot within a couple of weeks? Probably not. These are assumed to be pretty persistent characteristics of yourself, so you can wait a few weeks between those. And what we want to do is we want to measure this with correlations between tests. So what we can do is we can look at your performance on the first test, and we can look at performance on the second test and get a correlation coefficient for them. And if it's high, we can assume that it's reliable. So one of the ways that we can actually measure this, by the way, is with something that is called Cronbach's alpha. That is a pretty common measure for test-retest reliability, and it might pop up on your quiz. Yep, there it is. So I want to talk a little bit more about reliability on tests. So we want to make sure that, that every time that you take a test that measures a certain characteristic, that it's reliable. Now, likewise, let's say that I am giving you a big 5-factor test. So we're looking at a test that kind of measures conscientiousness, agreeableness, openness, extroversion, and and neuroticism. So we're looking at all of those different measures. Now, if I ask you how conscientious you are, am I just going to have one question on the test, on the inventory for that? No, I usually have multiple questions to gauge your conscientiousness. So oftentimes we're going to have multiple questions that look at the same facet of your personality. So in this case, we want to look at what is called internal consistency reliability. This is the consistency of a measure within itself. So all of my questions that look at extroversion, if you're an extrovert like me, and you perform high on one question that looks at extroversion, I should perform high on other questions that look at extroversion. Does that kind of make sense? So these kind of questions that are all looking at the same thing, they should all be consistent with themselves, and they should all correlate very highly. And that is what Cronbach's alpha looks at. Generally, we find that if we look at these pairwise comparisons between items, and if the Cronbach's alpha is higher than 0.7, we're going to go ahead and say that this measure is pretty consistent. So this is based off of recommendations by Nominal. One other thing that I would kind of recommend is if you want to get a more reliable measure, generally the higher your reliability, the better, but there is kind of a trade-off between reliability and how valid the measure becomes. But there are a couple of other ways that you can enhance your reliability. You can make sure that your test questions all fit with each other very well. And you can use a scale that is known to be reliable as well. Does anybody need some more time here? Okay, so what about validity? So I mentioned that a bathroom scale can't tell you anything about your personality or your worth as a person. Should you expect it to? No, not at all. So when we talk about whether or not a bathroom scale can measure aspects of your personality, we are now moving into talking about what is called validity. Does the measure actually measure what it says it will? Now, generally, a measure that is valid should be reliable. But just because something is reliable does not necessarily make it valid. And there are 4 different types of validity that we can talk about here. So we're going to talk about face validity, content validity, criterion validity, and construct validity. You're going to hear more about construct validity in particular in Chapter 6 when we talk about surveys and observational research methods. All right, everybody good? Okay, so face validity, what happened to that picture? Let's fix that. That was new, there we go. Okay, so face validity is basically the degree to which items on a measure appear to be reasonable. So we're talking about face value here. So for example, if I ask questions about extroversion, something that has high face validity would be something like, I enjoy being around people and making small talk. Now, on the face of it, that sounds pretty reasonable. That may not be a great measure of validity, though. Now, let's try another example. If I'm designing a test that examines reasoning ability, what kind of questions should I have on it? So your ability to reason, what kind of questions should I have on there? Should I just have math problems? Probably not. What else should I have on there? Maybe some analogies. How many of you remember those? You're like, please don't make me do those again. Maybe reading comprehension. Maybe looking at graphs and trying to figure out what they mean. So all of those are different ways that we do reasoning. And at least on a surface level, they look pretty good. But here's what's really critical. Just because items on a test look good does not mean that the test is scientifically valid. For example, most BuzzFeed quizzes and most quizzes at the back of Cosmopolitan. All of those have really good face validity, but they don't actually tell you anything scientifically valid. It's not necessarily a scientifically valid measure of what drink I should get at Starbucks. They always tell me I should get a peppermint mocha anyway. Now, what about content validity? So content validity is basically, do the items accurately represent the range or the set of items that could have possibly been included? So, hey, are y'all aware, if you're psychology majors, that you have to take a field test on assessment day when you in the year that you graduate? You got to take a test on different aspects of psychology. Not because you'll be graded on it, but we do it for assessment purposes. You get asked a bunch of questions in psychology that you hopefully experienced throughout your 4 years in the program. So how annoyed would you be if they were all biopsych questions? You would be like, I would be very annoyed. Is psychology just biopsych? No. What other kinds of questions should we have in there? We should probably have some research methods. We should probably have some developmental. We should probably have some abnormal, maybe some personality in there as well. So we want to make sure that we are covering the actual breadth of the field. So as another example, reasoning ability involves things like math, verbal, logical reasoning problems. I am doing my test a disservice if I give you a reasoning test that only involves math. So I need to include all possible items. So if you're thinking of developing a test like this, it involves some careful planning on your part. And then we have criterion validity, and this is where Dr. Gilchrist gets annoyed at college entrance exams. I am not the best standardized test taker. Like, for me to do well on I do well on those standardized tests they gave you in school once a year, but I was not really a very good test taker for the SATs or anything like that. So criterion validity is basically how well a measure predicts an outcome. So one of the things that we've often heard, or at least I heard a lot when I was in college, was that performance on the SAT predicts your grades in college. So this is what is known as predictive validity. So what we do We give a bunch of high school students the SAT, and then we follow up with them in the future and see how their grades look. And we look at the relationship between their SAT performance and their grades. So this is what we call predictive validity. Fun fact about the SATs, by the way, while you're writing this down, they only predict the first semester's college grades, and they also tend to underpredict in certain groups. And by certain groups, I mean groups that typically tend to be oppressed. They tend to underpredict performance. Now, another way that we can look at criterion validity, if we really believe that the SAT predicts college grades, we can give college students SAT questions and see the relationship between the grades that they are currently getting and how they did on the SAT. This is what is called concurrent validity. The measure is predicting a criterion that we've actually tried to assess at the exact same time. Okay, everybody good? Okay. So finally, we have construct validity. So this is when we are asking, does this measure assess the theoretical construct that it was designed to? So I'm going to use the dinkiest example that I use in every class when I teach research methods. I want you to imagine, so how many of you have actually ever done an intelligence test? Like, it's really long. It's usually for kids, it's about 2 or 3 hours. So it takes a lot of time out of your day. I had to do it once. I had to do it on a Saturday, and I was there until about noon. You have to do a lot of different tasks. It's really time intensive and exhausting. And so maybe I decide, hey, I'm going to design a better intelligence test that doesn't take as much time. And guess what you have to do? All you have to do is count marshmallows. That would be a really bad test, right? Because I'm not actually assessing intelligence, even though I claim to be. I am measuring marshmallow counting ability, which is not the same. Likewise, SATs are designed to measure scholastic aptitude. Aptitude is different than achievement. Achievement implies college grades. Like, college grades are an achievement measure. Aptitude is about potential. And some people have actually said, because the SAT only looks and only is really correlated with first semester college grades, and especially because it often underpredicts performance, that it's technically a form of consumer fraud. And as somebody who doesn't really like standardized tests, I am kind of inclined to agree. So how do we make sure that we don't fall into a trap of measuring something different than what we intended to measure? So first of all, we want to make sure that the other types of validity are present. So we want to make sure that we have our criterion validity. We want to make sure that we have maybe a little bit of face validity, but we want to make sure we have the other types of validity. Additionally, if I have a new intelligence test, it should correlate pretty highly with anything else that is an intelligence test, and it should not correlate with anything that isn't. So when my intelligence measure correlates with other measures of intelligence, we call this convergent validity. When our intelligence test when our intelligence test does not correlate with things that are not related to intelligence, we call that divergent validity. So another example to kind of make it clearer, let's say that I'm looking at a new inventory of depression. That should probably correlate pretty highly and have good convergent validity with something like Beck's depression inventory, right? That's a pretty well-known depression inventory. On the other hand, my depression inventory should not correlate with inventories that look at something like antisocial personality disorder. So I should get convergent validity with other depression measures. They should correlate with each other. And I should not get correlation with antisocial personality disorder. So those should not correlate with each other. Okay, so we've got about 10 minutes left. Well, it's been a hard week. And to understand what I am about to show, to understand everything that I use for my slides, I feel like I have to briefly show you a cartoon. So when I record this, I might have to trim this part out. If you do not want to watch the cartoon and you're zooming in, that's fine. But if you want a little bit to relax, how many of you are familiar with Animaniacs? Okay, a couple people. It's a cartoon I very much loved when I was a kid. And we're gonna watch a quick cartoon about ladies who give surveys. It's about 5 minutes. All right. Oh yeah, I can't be on premium. I'm not used to seeing ads. I have premium. Okay. Share computer sound.